Okay, so this next question, question 2, is a little bit different to the first one we looked at, where an object was thrown off a cliff. What we've got here is an object being thrown from the floor. So the first thing we're going to need is a floor. Why not make it out of grass? Something like this. Because if we're throwing a ball, it says an object, I guess it could be anything. But if we're going to throw an object, it might as well be on grass. So let's draw our velocity vector that we're going to start this whole question off with. So I guess we're going to assume that it comes from the floor, and we're going to assume it looks something like this. That is our velocity vector. That velocity vector has a value, a magnitude of 40 meters per second, as given in the question. The other thing we're given here is the angle, and that is this angle here. It's above the horizontal, this angle here. And this angle is 30 degrees. 30 degrees. I'm not going to be able to do degrees, so let's just stick this in a little bit smaller. 30 degrees. Okay. Now, from here, I can figure out the horizontal and vertical components of the velocity. Because in reality, although this object is moving in this direction, you can kind of simplify it and say, well, it's moving upwards and it's moving sideways at the same time. So let's bring in our horizontal vector. That's going to sit around here. Actually, let's make that a little bit thicker so it overwrites the grass. That's going to come this way and give a head on that arrow. And then at the same time, we've got our vertical vector, and that's going to come up like this. And it should kind of form some kind of right-angled triangle. There are loads of different ways to draw this, and everyone's got their preference. But this is mine. Vertical, horizontal, and the resultant in between them. So let's label the values of these. Well, the quick way of getting these is knowing that if you move through the angle, you do cosine. So this is 40 cos 30. Okay, you can prove that with trigonometry if you want to go the long route, but as long as you're confident with doing this, you can say that this one is 40 sine 30, because we moved away from the angle. These should have units. I apologize for that. I'm not going to go back and add them in, but they should have units of meters per second. So now we have a little bit of information. Let's do the horizontal and the vertical. So I'm going to have to do, let's see, S equals U equals. You think it takes you a long time to write these out. Oh man, what have I done? Oh no. Cancel. Because someone will say, Mr. Perry, you did capital letters. And of course it's not capital letters. I hope I didn't do capital letters in my last video. V equals, A equals, and T equals. Okay, I can't be bothered writing those out twice. I was going to do them in different colors. But let's copy and paste them. Because it's quicker, and then we'll say that one's vertical and one is horizontal. Let's bring that one down there, bring that one here. Let's have vertical as being this one, V, and let's have this one as being horizontal. Is that right? No, it's the wrong color, isn't it? This one's vertical, this one's horizontal. Okay, cool. So what can we write then? What are we even going to find out? I don't even know. I didn't even look. I've just been drawing stuff because like these questions are always similar. You always got to resolve vectors and stuff. So I've got to get the time of flight, the maximum height, and the horizontal range. So time of flight is going to be one of these, the t's. The maximum height is going to be the vertical displacement, possibly at one point. And the horizontal range is going to be the horizontal displacement. So what do I know? Well, let's fill in blue, first of all. Vertically, what do I know? Do I know the displacement? No. Do I know the initial velocity? Yeah, it's 40 sine 30. Yep. Do I know the final velocity? Haha, yeah, I do. It's 0 meters per second. Again, I've missed units here. I apologize. Make sure you have your units. 0 meters per second. Well, why is that? Well, let's come down here and let's draw a little picture of exactly what's going to happen as this object goes up. So it's going to come up, right? And can I actually do it like this? It's going to, yeah, there we go. It's kind of going to come up, and it's going to be like this, right? So here's our initial velocity. Let's draw some arrows on there so we can see it nice and clearly. Here's our initial velocity, and of course there is oh, that's gone wrong. It's going to go this way, and of course we can break that into the vertical and horizontal components. At the very top, though, its vertical velocity is 0. It comes up, and then its vertical velocity is 0, and then it starts going back down again. You remember right back a while ago, we did a question where we threw the ball up in the air. So let's do that. Take the ball, throw it up in the air, and it falls back down. And right at the very top, its velocity is 0. Now this is exactly the same, we're just in 2 dimensions. So it comes up here, its vertical velocity is 0, its horizontal velocity didn't change, and now it begins accelerating downwards still. No, it always was accelerating downwards, and now it's got a velocity in the opposite direction coming down, at least vertically. So it's very similar, up then down, it's just going sideways at the same time. And it doesn't matter that it's going sideways. That's the beauty of these equations. The up and down is totally separate from the left to right, and so you can treat them independently. Let's come back up to our question then. That's why it's got 0 velocity right at the very top. The acceleration, we know that, don't we? That's well, this is interesting actually. So have a think to yourself, is it positive acceleration or negative? So I'll give you 5 seconds. 5, 4, 3, 2, 1. It's minus 9.8 meter per second squared. Just about fits in there. So why is it minus? Well, I didn't actually declare, did I, that this way is going to be positive this time. Why is that? No reason, I just felt like it. But the initial velocity was positive, 40 sine 30. So if I'm saying that that's a positive number, the acceleration is in the opposite direction, it must be a negative because it's a vector. So immediately I've got 3 things here. Hopefully I can figure out some stuff with them. I've just realized I've done these all in the wrong color. Oh well. So let's go over onto this side. Let's stick in blue just so that it doesn't get confusing. What do I know about the horizontal? Well, I don't know how far it goes. That's the final part of the question. Do I know how fast it's going? Yeah, it starts at 40 cos 30 units meters per second, but you can see they're not going to fit, so let's not bother. Actually, no, let's bother. I don't even care. Oh, I do care. Don't bother. You need units. Don't forget. Acceleration 0. If I really wanted, I could add the velocity, the final velocity as being the same as the initial, but it's kind of not that big a deal. And that is about it. Let's stick that in. Why not? 40 cos 30. So this time, what have I got? Well, I got 3 things here, but they're kind of useless. That's why I was hesitant to put the V in, because you might trick yourself and say, oh, I've got 3 things, but you won't really work anything out with them because they're all so similar. Over here, though, I've definitely got some stuff I can work with, and the first thing is the time of flight. So let's use a suvat. We're going to use a V equals U plus AT. It's going to rearrange to give, there isn't an equation editor in here. It's going to rearrange to give, let's do it in green, T equals V minus U, V take away U over A. Okay, that's going to be the values we're going to use. So 0, take away 40 sine 30, divided by minus 9.8. You can see that because this is a takeaway, and because this value is negative anyway, we end up with a positive number as our solution for t. We'd be in trouble if we got a negative value for t. So I'm going to stick this in my calculator. 0 take away 40 sine 30 divided by minus 9.81 gives me 2.04 seconds. So let's stick that in there. Do it in a slightly different color to indicate I calculated this. 2.04 seconds. Okay, cool. However, that's not the actual answer here, because the 2.04 seconds was until it had 0 velocity. So if we come back down, that means that the ball, or whatever it was, went up here and it got to 2.04 seconds now. And then it traveled and continued on down this way. And the nice thing is the time taken for this half of the path is the same as the time taken for the second half of the path. So that means that the answer, the final answer for calculate the time of flight is double this. It's 4.08. So let's write that in here. The total time, we're going to write it up here. Total t equals 4.08 seconds. Okay. Cool, that's the first part done. Let's underline it to tell us that we did it. Good. The maximum height reached, that's going to be this one. So how am I going to do this? No, it's not going to be this one, is it? It's going to be this one, maximum height. So this is going to be, I could use s equals ut plus half at squared. I could use s equals v squared minus u squared over 2a. It's really up to you which one you do. There's honestly no difference. I'm going to use the one, I'm not going to use s equals ut plus half at squared. Let's go back to here. So I could either use 2 or 4 here. Because the thing is, both of them have the stuff I need. I'm looking for s. So you might immediately go to that one. The only problem with using this one is the value for t is the value for t that I calculated. And it's always better if we can to use the values we were given. And we're actually given all of these. Okay? You've got to rearrange it, but it's going to be s is v squared minus u squared over 2a. So let's get rid of this equation here. And let's draw in green, s equals v squared minus u squared over 2a. Okay, and let's find our value for s. So I'm going to do 0 squared, which is 0, take away 40 sine 30 squared, divided by 2 times minus 9.81. And that gives me an answer of 20.4 meters. Okay, so my answer there, let's bring it up here. Text. Max height equals 20.4 meters. Okay. Not too bad. Again, the negative signs cancelled, and that's good because I want a positive displacement because it's the maximum height. So finally now we get the horizontal range. Let's just highlight this one to say that we got it. Cool. And then the horizontal range. This one's really easy. We've now got a value for t. It's this 4.08. So have a think to yourself. Why is it the 4.08? Why isn't it the 2.04? Well, because this is the maximum range. So to get from here all the way over here is the total time. What speed we were going? We were going 40 cos 30. So this is simply s equals ut plus half at squared, but a is 0, so this bit disappears. We're left with s equals ut. Let's draw that out just as we did all the others. S equals ut. So I'm going to plug in for u 40 cos 30, so 40 cos 30 times by t, 4.08, and that gives me a total answer of 141 meters. So let's get that one, and horizontal range equals 141.3 meters, and that is my final answer. Think to yourself, does it sound reasonable? Let's bring all of these over here. So the ball was thrown up in the air at 40 meters per second. That's reasonably fast. How long was it in the air for? It was in the air for 4 seconds. Okay, it's not a long time, but you imagine throwing a ball. It's a while, actually, if you time 4 seconds for a ball to be in the air. But it's thrown pretty fast, that's okay. It went up to about 20 meters. Yeah, it seems reasonable. And it went a total range of 141 meters. So this is a very powerful throw. I think if you convert meters per second into kilometers per hour, how would you do that? 40, let's think, over 1,000? Yeah, 40 over 1,000 times by 3,600. In kilometers per hour, is that 144 kilometers per hour? So that's faster than, well, it's nearly double the speed limit on most of the roads here in Qatar. So yeah, that's really, really fast. So it makes sense that the numbers are big, they're on the large side, but they are kind of reasonable. And if you can appreciate that's a fast throw of the ball, you can appreciate the numbers are a bit bigger than what you'd get if you throw it. Because you're puny and weak, not like me. I would be able to throw it even further than this. Hopefully that all makes sense, and you've got an idea now of how to do this kind of calculation. Good job if you got it right, and go practice some more. Have a look online, find your own, and if you've got any